We are on part 4 of chapter 5, and in this section we are going to discuss methods of overcoming the limitations of IP version 4. We will discuss private IP addressing, also known as NAT, Network Address Translation, and we will look at IPv6. Private IP addressing, NAT, is where many computers can share one public IP address. To understand why we need to do that, let's review the TCP/IP 32-bit address space. An IP address is made up of 32 bits, 4 octets, and each octet is made up of 8 bits. Well, the limitation is that if you only have a 32-bit address space and you take 2 to the 32nd, that's a maximum of 4 billion IP addresses. The population of the planet is 6.5 billion, and many people have multiple IP addresses. So the statement of the problem is that we are running out of IP addresses, and there are two potential solutions: IP version 6 and private IP addressing using NAT. With NAT, many computers share one public IP address. But let's back up and discuss the difference between a public and a private IP address. A public IP address must be globally unique. Globally unique means that no two computers on the face of the earth should share the same IP address. And it used to be all IP addresses were public IP addresses. But now there is something called private IP addresses, and private IP addresses are used within an organization. And many organizations can use the same internal IP addresses. These private IP addresses are not globally unique, and they don't go over the internet. So here's what we do. We have many computers which are using private IP addresses, and they all share one public IP address. If we look at the example of CCBC and Howard Community College, CCBC uses the internal range of 10.0.0.0, and so does Howard Community College. But I thought no two computers on the face of the earth could use the same IP address. Well, that's true with public IP addresses, but with private IP addresses, different organizations can use the same IP addresses within the organization. And then the router is the only thing that has to have the public IP address. The public IP address has to be globally unique, and that is what connects to the internet. So NAT, the Network Address Translation Protocol, is the software that runs on the router that allows many computers running private IP addresses to share one public IP address. Thus, at CCBC Catonsville, instead of needing 3,000 IP addresses, we only need one public IP address. Same with Howard Community College. Instead of needing 3,000 different IP addresses, they just need one single public IP address. This is an example of a large organization. Now, if we look at a small organization, such as a SOHO, small office, home office, they also have many computers sharing the same public IP address. Many of us are using private IP addressing at home, but we don't think about it because it's taken care of by the wireless router. But you can see the computers within the home network all have private IP addresses, and they all share the one public IP address that goes to the cable, which is used by the cable modem. So private IP addresses used by large organizations, a Class A network, would be in the range 10.0.0.0. That's what's used by the Community College of Baltimore County. And then a Class C private IP address would be 192.168.1.0, and this is what most of us are using on our wireless computers at home. And all of these computers using a private IP address within the organization are sharing a single public IP address, and it is the network address translation protocol on the router that allows many computers to share a single public IP address. NAT allows many computers to share one public IP address, and it addresses the problem that we're running out of IP addresses. Now let's go to IP version 6. As you know, the limitation of IP version 4 is with a 32-bit address space, we only have a total of 4 billion IP addresses. So, two potential solutions: NAT, as we've already discussed, and IP version 6. IP version 6 has a 128-bit header. If we take 2 to the 128th, that shows us that there are 340 trillion IP addresses available in IP version 6. So that would be an IP address for every cell in the body of every person on the face of the earth, with plenty of IP addresses left over. There are lots of IPv6 addresses. In IPv6 addressing, it is written in a different format, whereas an IPv4 address is 192.168.10.100, what we call a dotted decimal notation. IP version 6 uses hexadecimal. It uses 8 hexadecimal blocks of 4 hexadecimal values to represent that 128-bit header. So hex looks kind of hard, but if we look at hexadecimal notation, we can see that the number 1 is represented as a 1 in hex. The number 9 is represented in 9 as 9 in hex. No problem there. But 10 is represented as an A in hex. 11 is represented as a B in hex. 15 is represented as an F in hex. Why do they do that? Because higher values can be represented with a lower number of characters. In hex, 9 is a 9, 10 is represented as A, and 15 is represented as F. So if we look at this IP address, we can see that the network ID is 15. How do you get that? Because F is 15. And the host ID is A. A is 10. So you can see it's network 15, workstation 10. Now, we can represent this whole string of zeros as simply a double colon. A double colon represents a long string of zeros. You can only have the double colon once. And then you can get rid of these leading zeros since they're not necessary. And that shows that it is network 15, workstation A. So hex is a little bit overwhelming at first, but it doesn't take long to get good at hex. So let's say we're going to assign this hexadecimal number, this IPv6 address, to this workstation right here, address 2001:1001:1009. So I go into Control Panel, Network and Internet, Network Connections, and I select IP Protocol version 6, followed by Properties. And then I type in the IP address, which is kind of long, subnet mask of 64, and then the default gateway. You can see it's the same network ID, just a different host ID. And this is the IP address of the DNS server, which we will discuss later. So then, to test IPv6, just like IPv4, we use the ipconfig command. If we type ipconfig, it shows that this is the IPv6 address 2001:1001:1009. That is the IPv6 address. If I want to ping myself, I can type ping followed by my own IP address, and I can ping myself. If I want to ping somebody else, such as the DNS server, I can type ping followed by the IP address of that server, and then if I can ping that server, I know that that server is up and running. So you can see the ping command works the same way. In IPv6, you just got a slightly longer number to type out. To assign an IPv6 address is like assigning IPv4. You can walk up to each individual workstation and type in the IP address, or you can use DHCP to automatically issue the IPv6 addresses to the workstations. The DHCP server has a group of IPv6 addresses, and when the client boots up, it requests an IP address from the DHCP server, and the DHCP server pushes down an IPv6 address. DHCP works the same way, IPv4 or IPv6. So 3 ways that a workstation can get an IPv6 address: statically, dynamically using DHCP, and if the workstation cannot hit a DHCP server, it can generate its own temporary IP address, which begins with FE80. So if you see that a workstation has an IPv6 address beginning with FE80, you know it's a DHCP client that could not grab an IPv6 address from a DHCP server. IPv6, whereas IPv4 has only 32 bits for the address space and only gives us 4 billion IP addresses, IPv6 has a 128-bit address space, which gives a potential of 340 trillion IP addresses, and it is represented in hex. Chapter 5, Summary. In this chapter we discuss TCP/IP, the protocol that allows computers to communicate. We looked at the IP address, the subnet mask, and the default gateway. We looked at the ipconfig command and the ping command, and we looked at rules in IP addressing. We looked at the dynamic host configuration protocol, automatic private IP addressing in binary, subnetting, private IP addressing, also known as NAT, and IP version 6. And this concludes Chapter 5. Thank you very much,